Requirement Planning by YASH Technologies. Before we get into approach, let us reinforce our understanding of the material requirement planning. Organizations have to plan which products are to be produced and in what quantities. They should be in a position to forecast the requirements so that they are able to meet the current and future demand of the customer, and also it should manufacture the goods at lowest possible cost. If any organization is making a bad decision at any level, it would lead to an under-optimal production frontier, resulting in a failure in strategic business planning. So for this reason, an organization or an enterprise requires a well-integrated tool that could interact with all departments to carry out the business in a profit-making way. Material requirement planning is a production planning and inventory control system that integrates data from production schedules with that from inventory, bill of material, and other external factors to calculate purchasing and shipping schedules for the parts or components required to build a product. Today, we present to you YASH data science-driven approach and methodology to material requirement planning through advanced mathematical and optimization models. The platform provides the optimum purchase and production schedules, reducing the production losses and minimizing the cost. The platform developed takes ownership of the data from the quotation stage through the sales, the raising of the works order, through all stages of production, including stores, and some contracting through to dispatch and invoicing. Now, we'll be walking you through the solution and the demo that we have. So, coming to the demo, as we already discussed, material requirement planning is a tool to map the raw materials in the most optimal manner while doing production planning. The necessity to optimize arises from the fact of several choices of mapping with varied financial implications. So coming to the product, the platform has been developed on our platform, and the visualization and the user interface has been developed on our Shiny. Before coming to the platform that we have developed and we are showcasing here, the business overview and other nitty-gritties related to the product can be discussed over here. So coming to the business overview, the client is particularly a discrete manufacturing company primarily into metal fabrication. So the data has been collected from this particular manufacturer for the prototype that we have developed and showing over here. So the data includes information on coils, sheets, end bands of different dimensions of raw materials which are used to produce the final good. The cost of production significantly depends on the choice of raw material picked reserved against the line item of the bill of material. So this is a business overview to the problem, that is basically what kind of data the client has and what kind of information has been used over here to develop the platform, which we'll be discussing. Now coming to the SAP or the data source that we have, on the SAP platform, the sales orders are aggregated to generate a production order. SAP MRP gets triggered to either allocate or initial purchase requisition based on the unreserved stocks available at that particular raw material. Coming to the proposed solution in R, that what exactly we do is that we identify different raw materials that go into the production of a final good that we talk about, or a semi-final good, and each of the raw material that we're discussing about, we find out the optimal combination which would provide the feasible combinations that can produce a final good, and we identify what is the optimal combination of different raw materials that can produce that final good. So this optimization method has been carried out using R, and this is the final output that we show across over here. However, when it comes to the details of the platform, when we have multiple raw materials that contribute to a particular final good, all these raw materials simultaneously will be optimized, and that can be produced as a final output in the product that we talk about. Now coming to the objective function that we have already discussed about, but to conclude it to an objective function, the objective is to minimize the cost. The objective function returns the total cost of the raw material to be purchased, or the cost of the material that is wasted in stock, or conversion stock that we talk about, for example, conversion from coil to sheet in this case that we talk about, and other operational costs such as transportation costs between plants and so on. Coming to the major constraints that we discuss about is basically meeting the demand with respect to the total requirement in a particular day or the total production, and wastage below the defined threshold. So these are the major constraints that we consider away for the analysis, apart from the few more constraints that will be discussed over the product that when we take it further. Now, coming to the key benefits, we already discussed about it. The key benefits would be minimal wastage of the resources, the optimal raw material utilization. Also, it is very vital in making the production plan for a coming period of time. So this is a overview to the complete platform that we talk about. Now we will be moving to the input data. That is basically where the data is being extracted and data how it's been retrieved to the platform for further analysis. Coming to the input of data, we take the requirement from the SAP platform. Once we import the data from SAP, we get the option of get requirement. Once we click on the get requirement, as you can see here, the data would be imported to our platform. Once it is imported to our platform, we can analyze the data, analyze the raw data that we have with respect to each of the filter that we put in. And this data, once we descriptively analyze it, we can move to the analysis and the optimization part. Before we get into the analysis and optimization part, as you can see here, just to give a brief about the variables that we have with respect to the raw data, SFG.material is the semi-finished good that we talk about. And this is the total semi-finished good net requirement. So this is basically the ID which is provided, or how the particular material is being called, and the unique value, unique ID to it. And this is the total requirement in terms of a particular unit that we talk about. And this is the raw material. This is the length and the breadth with respect to that particular commodity that we talk about according to requirement. And this is the raw material which that particular final good will be produced. And this is the thickness of the raw material that we talk about. And this is the moving average price. And this is the total time that we take in terms of days or the units that we talk about. So this is the data, how the data is the variables which. So these are the order numbers that we have, different order numbers. And with respect to each order number, as you can see here, what are the different requirements we have and what are the raw materials that go into it. So this is the overall the data with respect to each of the order details that we talk about. This can be replicated to many number of order details that we have and many number of the final good material that we talk about, and the combinations of different variables that with respect to that can be retrieved over here. As you can see here, when you click the aggregate button, we get the aggregate of all of it for a particular period of time that we talk about, a particular cycle time that we talk about. So there's an aggregation of all of it. The finished good has been represented in different alphanumeric terminologies as such. This over here, IDs over here. And then we have the dimension that is required, and what is the thickness, what is the density of it, and also what is the total number of such combinations we will be generating over here. That is the total required quantity requirement that we talk about, and what raw material is going into it. We can have a bigger picture on the overall the consumption of the raw material can be observed over here. So for the cycle time that we talk about, this is the combination, and these are different requirements that we have over here. Now, once this is done, it's important to understand the conversion and the get stock options over here. So when we talk about get conversion, in the current scenario that we have considered, there's where we have to convert the coils into sheets for the optimal usage of the resources. So when you do get conversion, what it essentially does is that in the background, it basically converts the coils into sheets which are required for the processing of the final good. So this data has been analyzed over here in the background, and that get conversion, once it's done, that data will be generated internally. So for this, the input data is with respect to the coil's length, width, which will be provided as a different data frame to the input through SAP itself. And when it comes to get stock option, this is the second option that we have. When we come to the stock option, what happens is that we analyze what is the current inventory that is with the system, and how that inventory can be utilized for the consumption of the current final good that is required as a part of the production, and what are the raw materials that can go into it, and that will be analyzed in terms of the already existing inventory stocks that we have. Now we go to the run option, which you can see over here. What it essentially does is that it runs all the combinations of different costs that we already discussed about in the input data that we talked about, which we'll be having a better idea when we move further on the options and recommendation tabs that we have. But when you run this option, what it essentially does is that it goes to an output which produces understanding what are different kinds of costs that will go into a particular combination of good that we talk about. For example, if we take the dimension 217 into 1250, this particular unit combination, if we take from the coil that we talk about, what will be the total purchase cost attached to it, what is the total wastage cost attached to it, and what is the conversion cost attached to it, and what will be the total cost to produce a particular select final good that we talk about here. So before we start on this particular part, what the end user can do over here is that they can select a particular, any commodity that we talk about, any finished good that we talk about. It'll give you a descriptive idea about it. What is the length, breadth, raw material required for it, what is the thickness, density, and the final good total number of quantities that we require. And after that, it identifies all the possible combinations from the existing sheets or the new sheets that we have to purchase. What are the different combinations that we'll get? At the same time, when we get that combination, what will be the purchase cost, wastage cost, and other costs attached to it? And the summation of these costs will be provided as a total cost over here. Now, why we do this process is because this will provide us all the feasible ways a particular final good can be produced, and this is carried out computationally. And once we carry out computationally, we'll get thousands and thousands of different kinds of combination depending on the number of raw materials and number of final goods we talk about. However, with the very sample use case that we discuss over here, we get around 96 different combinations over here. So as you can see here, there are different combinations, and we'll get the final, what is the total cost attached to it for this particular final good that we talk about. Now, what happens is next after is that we optimize this. Now, optimization is the objective of over here is to minimize the cost. That is the objective function that we have. So when we move to the optimize option, it basically identifies what is the best combination that we can provide for a particular material that we talk about, a particular final good that we talk about. So that combination will be provided over here. As you can see here, it talks about total number of quantity required, what should be the length of it, short to breadth of it, thickness, density, and now it comes with respect to the details regarding the raw material attached to it. For example, it could be cut from a sheet, and it should be from the raw material, this particular unique ID, with the length of this much, with the breadth of this much, available stock details on it, used stock, purchase required or not, that will tell you now over here whether we need to purchase more or not to produce that particular good or not, and purchase stock, which is the stock that we have purchased. Now, in this case, we haven't purchased, or if we need to purchase, we can see how much do we purchase. That information is provided, and the total wastage and the cost attached to the purchase is shown over here. So this is the final output we get, and this output will be provided for every specific, every unique final good that we talk about. In this case, we are talking about 15 different kinds of final goods that we over here. That's why we're showing only 15 entries. In the case of real world problems that we in the industry, we might face up to more than 200, 300, or thousands of unique products that could be developed, and this can be scaled up to that extent. And in the implementation and the deployment, that's what we usually do with the number of products when it comes to it. We scale up the platform with respect to that particular problem. So this is an aggregation of the above table that we have, and it shows in details about each of the particular coil each of the material or the final good we talk about, and what are its features attached to it. However, so this table provides the final output on how different combinations and how we can optimize the raw materials to produce those final goods, and what is the combination of the raw materials that need to be developed to get the final produced goods in this manner. So with this, now we move to the final part of it, which provides a descriptive and a concluded final analysis on the data that we have. So over here, we provide information on basically all the descriptive analysis that is being provided over here. As you can see, what is the total purchase cost for that particular cycle that we talk about with respect to all the final goods? What is the total wastage cost that we attach to it? What is the total conversion cost and stock utilization with respect to the previous stocks that we have and the current one? This is a descriptive analysis on each of these stocks that we talk about. What are the, how much has been needed to be purchased to produce it? How much had to be spend extra additional to produce that particular good. So all of those informations are provided over here. And also it provides an information on how much of the percentage of the production has come from the coils and how much of the production has come from the sheet. So this information has been provided accurately over here. And this helps in identifying and making a decision on, and also this is for a particular cycle time that we talk about. And that for that particular cycle time, what should be the combination of different raw materials that we have to produce this final all the goods that we have. So with that, we come to the conclusion on this and an end to this particular demo, which basically illustrates the platform where material requirement planning can be optimized and it could be availed in this way and produced the final output. With that, it comes to an end. Thank you.